All right, everyone, this is our last unit review before the final exam. We are going over parabolas. If you are going over, if you are, excuse me, if you are in regular algebra, you only really need to watch the first problem, and that is it. Honors folks, you for sure need to watch the rest. So in each of these cases, we're trying to sketch the parabola, okay? And the biggest thing that we need to be able to do is find the vertex. Because if we can't find the vertex of the parabola, we really can't sketch a solid graph. Um, it would be nice if you could find the x-intercepts and the y-intercepts very specifically. But in the end, I'm just looking for you to be able to create an accurate graph of the parabola, okay? So for this first one, reminder for standard form, the x value of our vertex is negative b over 2a. If you recognize that at all, it's because it comes straight out of the quadratic formula. Okay, so what we're going to do is we're going to label our a as negative 2, our b as 8, and our c, even though we don't really need it, it's good practice anyway, as negative 6, just like we do for the quadratic formula. Then we're going to evaluate the expression negative b over 2a. So b is 8. It's negative b, though, so we're going to make it negative 8. Put that over 2a, so 2 times negative 2. Do the math and simplify. That's negative 8 over negative 4, which is positive 2. Okay, so that only gives us the x value of our vertex. We now need the y value. So this is something that you've seen over and over again. You have an equation with an x and a y, and you just figured out one of the variables, in this case, x. All we have to do is plug in for x, which is what I'm doing right now, and that should give us the y value. Be very careful order of operations wise here. You need to do 2 squared first. And you're definitely welcome to have a calculator help you here. Wouldn't be the worst thing in the entire world. Then your multiplication. So negative 8 plus 16 minus 6. And I get y equals 2 as well. So my vertex is at 2, 2. The next thing you want to look at is whether your parabola opens up or down, meaning does it look like if it's up, it looks like a U. If it's down, it looks like an arc shape or an N. All you have to do to figure that out is look at the A value, so that negative 2 right at the beginning. Since that's negative, it's going to open down. So I'm going to draw my axis of symmetry going down. Okay. All I really need to do now is just start figuring out some points. If you wanted to figure out x-intercepts specifically, you could plug in 0 for y and try to solve for x. That would totally be possible. Or you could plug in some x values and kind of see what you get. The choice is really up to you. I'm going to plug in 0 for y, or 0 for x, excuse me. So I'm going to plug in x equals 0. That gets me y equals 0 plus 0 minus 6. So it gets me y equals negative 6. So I'm going to graph the point 0, negative 6. I'm going to use symmetry, and I'm going to get the point on the other side. Now I'm going to plug in, I'm going to have to do a little erasing here probably because I'm a little bit out of room. Now I'm going to plug in 1 for x and just see what I get. I have a gut feeling this is going to be pretty darn close to an x-intercept. So let's find out if I'm right. We're going to plug in 1 for x. And what I get is 0. So I plugged in 1 for x. I did all the math up there, and I got 0. So that means the point 1, 0 is on my graph. Turns out that was an x-intercept, and I'm going to use symmetry to get over to the other side. I've got a nice looking parabola, I've got the vertex, and I've got 2 points on each side. Awesome. And that's all we need. Number 2 is in vertex form. So this one should be much easier to figure out the vertex. Remember the way, and I tried to do a good job of explaining how to figure out the vertex. What you're basically trying to do is you're trying to make that little box there as small as possible because that's the part that's being squared. Okay, so you're basically trying to make that zero because as you get bigger than zero and square the numbers, you kind of get those repeat numbers on the other side when you go negative, right? So I square one, I square two, I square three. I get the exact same things as when I square negative one, negative two, and negative three. So the shorthand of it is this: figure out the x value that makes that parentheses zero. That's negative four. Okay. And then just like you do any other time you have an X value, think about what would happen if you plug that in. Or you could actually do the math, but what that's really going to do is it's going to make that whole thing turn into a zero because you're going to do zero squared, which is zero. You're going to multiply by a half, which is zero. And all I have left is y equals negative one. So my vertex is negative four, negative one. Now, if you're someone who likes stuff to memorize, okay, like you want to make sure that, hey, I might forget that or I might not remember exactly how to come up with that vertex when it's in that format, no problem. Just memorize what vertex form looks like and then know that you're taking the opposite of that number that's in parentheses with X and you're not taking the opposite of that number. Okay, so it was opposite of four is negative four, and the negative one was my extra number on the outside. I prefer to just kind of try to remember why it works, that I'm trying to make the parentheses zero, and then when I plug that in and see what's left, that's what I've got. And then, but if you don't want to remember that, that's okay. Now we really just need to find some other points. Now I'm going to use a little bit of intuition there, and that. Um, I know that if I plug in negative three for X, it's not going to turn out so well because I'm going to end up having to multiply by a half. So I want to make sure I've got an even number that I'm squaring there. So I'm going to actually plug in negative two for X. And I'm hoping that you'll see why I chose negative two as opposed to negative three. The reason I chose that is because now negative 2 plus 4 is 2. 2 squared is 4. So I'm going to do 1 half times 4. Okay. I get y equals 1. So negative 2, 1. Plugged in negative 2, and I got 1. Oops, forgot to draw my axis of symmetry. And I'm going to mirror that over on the other side. Now, unfortunately, this graph is not the most perfectly drawn thing in the entire world, so I'm going to have a little bit of trouble, I think, if I use 0 mirroring that over to the other side, but yeah, we can pretend. I'm going to plug in 0 anyway. So I get y equals 1 half, 0 plus 4 squared minus 1. I think that might have taken us a little too far away. Let's see. I get y equals 1 half times 16 minus 1. I get y equals 7. Unfortunately, that's a little bit too high for our graph. So it looks like we are going to need to go ahead and plug in negative 3. On your exam, I'll be putting the graphs on there manually. So you'll have a little more space to work with, which, I think should help you figure out some good, which will allow you to plug in kind of whatever x values you want. So let's go ahead and plug in negative 3. And I think we're going to be stuck with something with a half in it, but that's okay. We get y equals 1 half times 1 minus 1. That is negative 1 half. So I plugged in negative 3, and I got negative 1 half. Luckily, this graph is broken up into halves, so it makes it pretty easy to put that point on there and use symmetry, hopefully a little bit better. There we go, to get a pretty good idea of what that parabola looks like. Last but not least is intercept form. So for intercept form, you're going to figure out the x-intercepts first because those are the numbers that are easy to figure out there. Okay. And what that's going to involve is plugging in 0 for y. Now, once you plug in 0 for y, what you can see is you've basically got 3 numbers here that are being plugged in for x. or I'm sorry, that are being multiplied together. Okay, and some of them include x. So you've got -2 times x plus 3 times x plus 1. Those are your three numbers. Okay. Um, and so here's the deal, one of those three numbers has to be 0. Okay. Now you're treating those parentheses as if they're one number. Okay, so you're not treating x and 3 as two separate numbers. You're saying, no, 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 x plus 3 is a single number, x plus 1 is a single number. So here's the deal, the -2 can't be 0. There's no way to just turn a -2 into 0 because there's no variable. So what we're going to try to do is figure out what value of x would we plug in to each set of parentheses to make it equal 0. Well, blank plus 3 equals 0. That's -3. Blank plus 1 equals 0. That's -1. Those are my two x-intercepts. I'm going to put them on my graph. Now, the next issue I have is trying to kind of figure out, well, what do I do next? This is unusual. We're used to starting with the vertex. What I would kind of suggest you do next is put in the axis of symmetry. So basically understand that um, my graph is going to move down from there, but there's going to be a vertex probably a little bit above it. So I'm just going to try kind of draw my axis of symmetry just like that. Okay. And what that helps me realize is, oh, I now know where my vertex is. My vertex must have an x value of -2 because that's right in the middle of those two x-intercepts. How do I figure out the y value? Just like we have many times before, plug it in for x. I'm going to plug that into my equation. I get y equals -2 times 1 times -1. That gets me y equals 2. So x equals -2, y equals 2 is my vertex. I'm well on my way. I really just need one more point, and then I can use symmetry to figure out the fifth one. So I'm going to plug in a 0 for y, or for x, excuse me. I think that's a good one because I already have -3 is an x-intercept. -2 is kind of where my vertex is. -1 is where another x-intercept is. The next number in line would be 0. So I'm just going to plug that one in. And when I do the math, I get -2 times 3 times 1. And I get y equals -6. I plot 0, -6 down here. I use symmetry over to the other side. And once again, I've got a great view of what that parabola looks like. The last problem on here says convert the equation to vertex form. We didn't do that this year. There are a lot of different ways that you could convert it to vertex form. You could find the vertex and kind of figure it out from there. You could use completing the square to kind of do this, but in the end, we didn't go over it this year. So, hey, don't worry about it. That is it for this one. Doesn't look like I have a whole lot of viewers right now, which is understandable since pretty sure the Bucks are playing right now. Just kidding. I know the Bucks are playing right now. So if you are tuning in later and you have any questions on any of our stuff on parabolas, let me know. Hopefully this helped you out at least a little bit. Have a good night.